Welcome back to another video, and today we are doing a response to simulating the evolution of aggression. And what I want to do today is show you how to write a program that will demonstrate the evolution of aggression. So the video that we are responding to used a piece of software called Blender, and I've never used it, but I suspect it's much more complicated than what we're going to be doing. We're going to recreate that same program in about 30 lines of code. And we're going to do it in NetLogo. So download and install NetLogo. And then to set up the interface, you're going to need two buttons. So select a button, call it Setup, and select another button and call it Go. And we're going to go forever. So select this option here to go forever. And then we need three sliders. Now a slider creates a global variable. In any other programming language, global variables are discouraged, but they're actually encouraged in NetLogo. And we're going to have three sliders, one for the number of hawks in the program, one for the number of doves, and one for the amount of food. So I'm going to call the doves one num doves. And it goes from 0 to whatever. I've got 100 here. The increment is 1. That's all fine. Just leave that as standard. And there you've got this slider. And what it means is that a user can come along and select the number of doves they want to have appear in your program. So we need three of those: num doves, num hawks, and amount food. And then the only other thing that you're going to need is a plot. And just put a plot on like that. And I'm going to show you the setup of the plot later. So just leave it like that for now. And when you do all of that and arrange it so you can select and you can move these about wherever you want, it's going to look something like this. So here's my interface. I'm just going to tidy that up a little bit. Make it a wee bit prettier. Now, if you go up to this bit up here, we can select code, and that's all the code that we have to write. And I'm going to take you through this a little bit at a time. And this code has been written for simplicity. It has not been written for elegance, and it has not been written to make a pretty interface the way that the video we're responding to has. In fact, it's gorgeous. In the video that we're responding to, Blender has produced a really, really nice look. So let's dive right in. To have code execute when someone clicks on the setup button, what we do is we put it between the commands to setup and end. So all of this gets executed when someone clicks setup. So what do we want to do when we set up? You've got to clear all. Don't forget to execute the clear all command. That's the first thing and super important. That will delete the memory from the last time the program was used. Then we're going to reset ticks. The ticks, that's our counter, and we're going to need that just to make everything, make the timings on everything work essentially. Then all we have to do is set up the food, the hawks, and the doves. Now to set up the food, what we're going to do is we're going to ask the amount of food that the user specifies in the food slider. We're going to ask that number of patches to turn green. What does that do? Well, this bit here, this black bit, is our environment. It's made up of tiny squares. Those tiny squares are called patches, and some of them are going to turn green. How many? Well, it could be 50 if we set that to 50, or it could be 100 if we set it to 100. Ask n of amount food. In other words, we're going to ask a number of patches. We haven't got to that bit yet. Ask a number of, what should the number be? The number should be the amount of food global variable. So ask n of amount food. And who are we asking? We're asking patches. And then in square brackets, we're going to specify the code that we want those patches, those 100 patches to do. And we want them to set their P color to be green. Let's click on setup. And we see that we've got in this case 100 patches, that have turned green. And each patch represents an amount of food, and in the video that we're responding to, they used 2, so we're going to use 2 as well. So we're not going to include the number 2 here, but we just understand that those green patches in each time period have 2 pieces of food on them. Back to the code. The next thing is we're going to create a number of doves and create a number of hawks. Now there are a number of ways of specifying which of the agents are hawks and which are doves. And what I've done is I've created a breed for each. So that's this code up here. So I'm creating a breed of agents that I can refer to as the doves and a breed that I can refer to as the hawks. And that's really just for convenience. I don't have to do that. And the code is breed, open square brackets, and then specify a plural name for the breed and a singular name for the breed. So doves, dove, hawks, hawk. And then to create doves, I use the command create minus sign, create hyphen doves. And then how many doves am I creating? Well, it's the number on the slider, num doves. So create doves, num doves, and I've got them to turn blue because I think in the video they look kind of blue. We could also set shape to be person, and that would make it look a little bit better. And then do the same thing with the hawks. Now, what does that do? Well, all of our agents start in the middle square. In the video, they start in a big circle, and we can do that easily, but it's just going to add to the code. So I'm not going to do that now. That's something that you could investigate and improve later on if you wanted. And that's my entire setup. Then we do the same thing for the go button. So to, go, and end, all of the in between executes whenever someone clicks on go. And with the go button, because we selected it forever, this is going to go over and over and over again until we press go again to stop. Now the agents, all of those agents are referred to as turtles. So I can ask the doves to do something, I can ask the hawks to do something, or I can ask all of them to do something, and to do that it's ask turtles. So ask all of the turtles, set their food to be 0, because they've eaten whatever they captured, whatever they foraged yesterday. So set food 0. The next thing I want them to do is go and try and find some food. But I only want 2 agents to go to each green patch. So my line here says, first of all, are there any green patches that don't have 2 turtles on them? So if any patches with color equals green and count turtles here less than 2. So that's before they move, them looking to see, is there somewhere I can go that has enough space for me? And if there is, then move to one of patches with p color equals green and count turtles here less than 2. There's my command. Now, if there weren't enough green patches for all of my turtles to go and find some food, then the ones that are left, let's just get rid of them. We can do it now or we can do it later. I'm going to do it now just to get them out of the simulation. So ask turtles that are still standing on a black patch. So ask turtles with their patch color equal black, die. That's them gone. Then ask turtles that have found a patch all to themselves. So ask turtles with p color is green and count turtles here equals 1. So I've got to a green patch, there's only one of me here, I get to have 2 pieces of food. Set food 2. Now what's food? Well, up here we created a variable for all of our turtles called food. Turtles own food. Actually we've already used it, we've set it to 0 here. So set food 2. They're the ones that are going to get to survive another day and reproduce. Now, for the ones that are sharing a square. So if you're standing on a green square and there's two people on that square, you and someone else, what we then need to do is figure out, is it two doves, is it a dove and a hawk, or is it two hawks? And the way I've done that here is I'm asking the patches that have two turtles on them to kind of manage things. They're like the governor. So the patch is going to help me out here. And the first thing I'm asking the patch to do is specify one of the turtles on it to be turtle A and one of them to be turtle B. And that's what this bit here does. So that's specifying A, and then A will tell the other one that they are B. So I've got my two turtles, A and B, and what I would want in any other programming language is a select case statement, but NetLogo doesn't have a select case statement, and we could do this next bit with a series of if-else statements, but I think it's probably easier to understand if you've never used NetLogo before, just to go through it with 4 separate if statements. And if A is a dove and B is a dove is the first one. If A is a dove and B is a hawk, that's the second. If A is a hawk and B is a dove, or lastly, if A is a hawk and B is also a hawk. So that's my 4 if statements. They're almost identical, so we'll just go through one of them. So if A is a dove and B is a dove, then we've got square brackets to specify what those two things do, what those two agents do. And if they're both doves, they both get 1 item of food. So if they're both doves, ask A to set their food to be 1 and ask B to set their food to be 1. And all we have to do is specify the other numbers for the other situations. So if they're both hawks, they both get 0. If one's a hawk and one's a dove, the dove gets 0.5 and the hawk gets 1.5. And that's all that is. And then these two close brackets are closing brackets from before. And if you're new to NetLogo and you want to give this a go, where you will get lost is probably in the square brackets. And then after everybody's foraged for their food, ask them all to move to one of patches with p color equals black. So get off the green square. And lastly, all we're doing is sorting out who lives, who dies, who reproduces, and who doesn't. So if food equals 0, then die. If you didn't get any food, you die. If you got 2 pieces of food, then hatch another version of yourself. In other words, reproduce. So the command to reproduce is hatch, and we just want you to have 1 baby, so we hatch 1. Now, if you've got 0.5 food, then there is a chance that you'll die, and the chance is 50-50. So you toss a coin, and this is my coin toss. So if random float 1 is less than 5. So give me a random number between 0 and 1. If that is less than 5, that's the 50-50 chance. We're going to tell you to die. We don't have to do anything if you live, because we just let you live. And should that be less than or equal to, could that introduce a bias? To figure that out, you'd have to check the NetLogo user instructions user guide. But it's not going to make a huge difference here, so I'm just going to leave it as less than 5. And then if you've got 1.5 food, we toss another coin, and this time, if it's successful, if you're successful on the coin toss, then you get to reproduce, so you get to hatch 1. And the last thing there is a tick command that's just going to update the counter. And that is it, that's our program. And the plot here, I'll show you what I've done for that in a moment, but there's no coding involved there. It's just settings on the plot itself. Now, if we run this, it's going to go crazy. You're not going to be able to see what happens. So what you need to do is turn down the speed. So make it slower and then go, and you can see all of the doves going about their dovely business. Have it as slow or fast as you want. In the video, I think we saw about 10 goes. So we're up to 5 already, and there's our doves leveling off. That's their carrying capacity, essentially. That's the carrying capacity of those green dots. So they've reproduced and found their level. Okay. Speed it up again to do the setup, otherwise we'll be here all day. Now we'll put in one hawk, hit setup, and slow it down and see what happens. And this is, I think, the first thing that the video does is show what happens with a bunch of doves and one hawk. And I've got 2 lines. Now you'll notice that the plot that we're able to create in NetLogo isn't as pretty as the Blender plot, but we're just going to have to live with that. I don't think we'll be able to get as nice a plot in NetLogo, but if you want to investigate it, you could export the data automatically from NetLogo into R and have R do a nice plot. And you can see we're approaching 50% hawks and 50% doves. Those lines are about to touch. No, they're not. Okay, let me show you the commands for the plot. We want 2 pens, a red one and a blue one and a red one. And the plot is just, the plot command is just plot count the doves and plot count the hawks. And you can add a pen by clicking there. And you can just leave all of these as they are, the defaults, or you can experiment with them later. And that is it. So there you go, about 30 lines of code, and we've been able to recreate the same simulation from the video. And what I will do is I will post this code in a comment below, and you can copy paste and edit the software as you want and improve it. If you like these videos, subscribe down here somewhere, hit that bell notification and smash like, and I will see you on the next one.